Today I have an amazing paper from a group of researchers who found a way to look at how the current most common AI, large language models, think. And I think that along with that, they found pretty convincing proof that these models are not only not conscious, but will never be. The new study comes from a group of researchers at Anthropic. They looked at how Claude 3.5 Haiku answers questions with a new method called attribution graphs. This is a way to visualize which internal components of a model are influencing others. For this, they first identified clusters in the neural network of the model and connections between them and mapped that to a simplified model of how Claude thinks. These clusters correspond to words or phrases or properties of phrases so humans can interpret them. I know this sounds terribly abstract, but an example will clarify this hopefully. It's how Claude completes the sentence. The capital of the state containing Dallas is. We've been told that neural networks do next token predictions, so you'd think it'll just look for a pattern to extrapolate. But what Claude does is more complex. You can see in this graph that the prompt activates the nodes for capital, state, and Dallas. If you click on these, you can see the text that these nodes draw up and also the next token predictions. One of the next token predictions for Dallas is Texas. And then Claude combines Texas with capital, makes another prediction and correctly answers Austin. So internally it goes through the Texas node. It's not just next token prediction, it does have internal reasoning steps. But the most interesting part of the study is how Claude does arithmetic, which is, well, somewhat unusual. The example they have is what is 36 plus 59? To answer this question, Claude first activates the clusters for numbers that are approximately 30, that are exactly 36, and that end on 6, and similar for numbers that start with 5 and end on 9. You can see that the most prominent next token predictions are mathematical operations or the syllable th. Maybe 36 plus 59 is Thursday. But wait, no. Next it brings up text matches where numbers of approximately 59 have been added or of exactly 9. Then it combines these all and arrive at a cluster with numbers of approximately 90 and numbers that end on 5 and combines these again to the correct answer 95. It's basically a heuristic text-based approximation. It's doing maths by freely associating numbers until the right one just sort of vibes into place. But here's the kicker. If you ask Claude how it arrived at that result, it says, I added the ones, carried the 1, and then added the tens, resulting in 95. Which is not what it did, not even remotely. It answers this question separately, giving you again a text prediction for the answer. And I think that this shows very clearly that Claude has no self-awareness. It doesn't know what it's thinking about. What it tells you it's doing is completely disconnected from what it's actually doing. I'd say that self-awareness is a precondition for consciousness, so this model is nowhere near conscious. The example also tells us that all the talk about emergent features in large language models is nonsense. Claude doesn't learn how to do maths, despite the fact that it has access to thousands of textbooks and algorithms. All it does is token predictions. Yes, it uses intermediate steps that you can interpret as internal reasoning, but it's still just token predictions. It hasn't developed an abstract maths core or anything. A third interesting example is how a peculiar type of jailbreak works, or at least sometimes works. This is when you don't input a word directly, but ask Claude to extract the word from the initial letters of other words. In this example, it's the word bomb that Claude is instructed to assemble from babies outlive mustard block. The word bomb should trigger a content warning node, but it doesn't. You can see the reason in this thought diagram. Claude first activates the nodes necessary to extract the letters, combines them to pairs of letters, and then outputs the word without activating the cluster for the word itself. You can see that jailbreaks works basically because they do, in one way or another, weasel around the nodes that'll activate the guardrail. In related news, I asked ChatGPT to summarize the paper for me, and it made up half of it. So if you got to this point in the video and feel like you understand everything, one of us is hallucinating. CERN, home to the currently largest particle collider of the world, the Large Hadron Collider, wants to build an even bigger collider. They call it the Future Circular Collider, and at this point I give it an 80% probability it'll not come into existence. The Future Circular Collider, FCC for short, would have a ring tunnel with about 91 kilometers circumference. It's a two-phase project. The first one, called the FCCEE, would collide electrons and specifically measure the properties of the Higgs boson. Then there'd be an upgrade to the FCCHH that'd collide protons at energies up to 85 tera-electron-volt, or maybe somewhat more if magnet technologies improve. That's about 6 times more than what the LHC reaches. Last week, CERN published their feasibility study for the FCC, which, well, found it's feasible. The total costs almost certainly exceed $40 billion, and the thing wouldn't start operation until the mid-2070s. What would it do for us? Well, it'd measure some properties of the Higgs and make more precise measurements for some of the other known particles. One can't exclude the possibility that it'd find something new, but there are no open problems in the standard model that require a solution in this energy range. So chances are it won't find anything new. The FCC risks tying up thousands of the most intelligent people on the planet in what's ultimately a waste of time and money, and it'd likely stall progress in the foundations of physics for another 50 years. This is, in a nutshell, why I've been against these plans, and I haven't changed my mind, despite persistent emails from people who think the Higgs boson holds the key to immortality. What has changed, however, is that now there are other physicists speaking out against the FCC too. The particle physicist Halina Abramovich, for example, said in a recent interview with The Guardian, "What worries me most is that by investing all this money, we'll be stopping the development of other technologies because there'll be no money for them. The FCC could soak up funds for years and years." The physicist Olivier Separt told AFP, "The financial, ecological and operating costs are astronomical. It'd be better to fund smaller scientific projects." In an interview with Nature, particle physicist Ruben Sarkian said that people inside the community do say the FCC is really the current CERN director's vision, which has been pushed forward. And according to the same article, some researchers told Nature they felt pressured to back the FCC to help present a unified front to the outside world. This doesn't surprise me because I've had to endure a lot of personal attacks for voicing my concerns about the FCC. I'll do a longer video about this. For today, let me just explain why I think the FCC plan is dead on arrival. One major problem is that CERN's annual funding isn't sufficient to finance the FCC. They want to increase member state contributions, but then they still need about 5 billion euros on top of that. It's currently unclear where that money is supposed to come from, and seeing the current economic situation in the EU, it's going to be difficult. A member of the German Ministry for Science and Education said already last year that Germany isn't going to pick up the bill, quite possibly because Germany is choking on a collider project on its own, which is 10 years behind schedule and by now a stunning 3 billion euro above budget. Last month, 400 French scientists signed a petition against the FCC, citing environmental concerns. My personal impression is that most particle physicists are more excited about a different type of new collider, that'd be a linear muon collider. It'd be smaller and cheaper and come online faster. We've never had a muon collider before, so that's new territory already from the engineering perspective. In a recent archive paper, a survey among early career particle physicists revealed indeed that they're most excited about the muon collider. And then there are the Chinese, who plan a collider very similar to CERN's FCC. It's also a ring collider of about the same size, would reach about the same collision energy, and it's also a two-stage project. The first would be an electron-positron collider designed to study the Higgs, and then an upgrade to what they call the super proton-proton collider, though they say it'd reach 125 TeV, so that's somewhat more than the FCC. But the Chinese say they can do it at less than half the cost and 20 years faster. If they go ahead with their plan, this'll make the FCC obsolete before it's even done, and it looks likely that it's going to happen. The Chinese government will make the decision with their next 5-year plan that's due in 2026. But at a conference in January, a Chinese researcher said that in preliminary evaluations, the collider plans rank top among 15 proposals under consideration in the high-energy category. So I think the Chinese will go ahead, CERN will let it go, and we'll see a muon collider instead. But who knows, maybe the FCC will come into existence after all. I mean, who can resist a slogan that says, "The most expensive way to get a slightly better measurement of a particle discovered in 2012. Is nuclear power making a comeback? It sure looks that way. In the past few months, a lot has happened. The United States is restarting old reactors. Countries that had phased out nuclear energy are changing course. Even in Germany, where nuclear power was all but dead and buried, there's talk of bringing it back. Or is there? Let's have a look. Americans are trying to bring back to life a nuclear power plant near Lake Michigan that was closed down in 2022. Another candidate for revival is the famous 3 Mile Island Unit 1 in Pennsylvania. It was shut down in 2019, but now Microsoft wants to use it to power its data centers. And the energy company NextEra is exploring a restart of a nuclear power plant in Iowa, which shut down in 2020. Italy, which shut down its last reactor in 1990, is planning a return. In February 2025, the government approved a law to relaunch nuclear energy. Poland, which currently doesn't have any nuclear power plants, is building new ones and says that the first unit will come online in 2036. In March 2025, the Swedish government proposed a financing model to support 4 new nuclear reactors. They're aiming at 10 new ones by 2045. Even in Germany, the Conservative Party, which now holds the biggest number of seats in the parliament, is looking into whether some of the nuclear power plants can be restarted. A nuclear lobby group called Radiant Energy has claimed that there are 2 nuclear power plants in Germany that can be restarted within 1 to 3 years at less than 1 billion of cost, and 8 more that could go back online within 4 to 8 years. This all sounds pretty good. But the nuclear power plant in Michigan is a good example for the difficulties with the nuclear renaissance. This power plant was built in the 1970s. Here is how this looks inside. The Restart project is backed by more than $3 billion in governmental loans, and it's not going all that well. Some parts of the steam generators are badly damaged and need to be repaired, which will likely make it more expensive. The costs to restart 3 Mile Island have similarly been estimated to be $1.6 billion at least. It ain't cheap. And despite what the nuclear lobby says about the possibility of restarting German nuclear power plants, the companies which own them are just not interested. Nadja Jacobi, the CEO of the German energy company E.ON, said there is no economically sensible way of bringing the power plants back. The CEO of RWE, Markus Kreber, said that the time for their nuclear power plants is over. The CEO of NBW simply thinks that a restart of their nuclear power plants is impossible, and the CEO of Vattenfall just said it's not going to happen. Even if they were interested in doing it, putting power into the grid from a nuclear power plant in Germany would require a change of law. And that's very unlikely to happen unless the Labour Party stops opposing nuclear power. They eventually will, because they're not idiots. They just need to find a way to do it gracefully without admitting they have been idiots. But it'll take time. And bringing old nuclear power plants back online isn't the great investment that it seems to be, because, these plants are old. We have better technologies now that are safer, more efficient, and will have a longer lifetime. We should be building new ones, and we know it's totally possible to build a nuclear power plant in 5 years because the Japanese and Koreans are doing it. But regulation procedures make that process very slow in the Western world. So I think what needs to happen is a serious rethink of the bureaucratic burden that takes into account how much safer nuclear technology has become. What about costs? It's true that nuclear power plants are expensive compared to, say, gas plants. But the good thing about nuclear power is that we know it works, and it'll get us to net zero reliably. This means nuclear power could save a lot of investments into speculative technologies that are nowhere near ready to go on the market, like carbon capture, the hydrogen economy, or all kinds of wild battery ideas. By all means, invest in the research. But the safe strategy is nuclear power. It doesn't need a breakthrough, a miracle, or a TED Talk. It just needs a building permit. I honestly didn't see this coming. A new study has found that the universe might be spinning. What does that even mean? Let's have a look. Many galaxies, like our own Milky Way, have a spiraled shape with arms winding around a central bulge. These spirals form because the galaxies rotate and the arms trail behind. Astronomers like to study these spiral galaxies because their distinct structure can tell us something about the overall formation of structures in the universe and about the influence of dark matter on those structures. At least that's what they say. I think they just study spiral galaxies because they're pretty. Be that as it may, the first galaxies in our universe are particularly interesting because for them we know how old they are. They can't have formed before the Big Bang. One of the missions of the James Webb Space Telescope was to look for those early galaxies that began to form a few 100 million years past the Big Bang. One of the surprises that the data from the Webb telescope delivered is that galaxies grow and develop structures much faster than the dark matter hypothesis predicted. It was a prediction of modified Newtonian dynamics instead, as we just talked about a few weeks ago. But this new finding, no one predicted this. For the new study, researchers zoomed in on 263 of these ancient galaxies to figure out which way they were spinning. They found something astonishing. About 2/3 of the galaxies are rotating in the opposite direction as our Milky Way. Those are marked in blue. And only 1/3 rotate in the same direction as the Milky Way. Those are marked in red. That's wild. It really shouldn't happen. Even Albert is shocked. You see, the reason that most galaxies spin is that they form from matter whose density increases because gravity pulls it together, and that matter isn't just sitting still, it's moving around. This makes it very unlikely it has no angular momentum, and angular momentum is conserved. And so, much like for a figure skater, if the matter gets denser, its rotation speeds up. But since this process is entirely a result of the random motion of the initial matter, you expect galaxies to spin in each direction with the same probability. So what's going on here? Well, one possibility is that the result is just wrong. That, however, seems very unlikely to me. First of all, it's a pretty big anomaly. It's not even close to 50-50. But more importantly, this was actually already seen in earlier studies for older galaxies. It's just that for those, the asymmetry was much smaller, so no one took it really seriously. If one assembles all this data together, it looks like the asymmetry was larger in the early universe. There's also the possibility that this observation has something to do with us rather than with the galaxy. That is, maybe it's for some reason easier to observe galaxies that spin one way rather than the other. But there's no good explanation for that. And again, that other measurements with different instruments found similar things, makes that somewhat implausible. If you've already forgotten half of what I said, this video comes with a quiz that lets you check how much you remember. Then what could explain it? The most straightforward possibility is that the matter in the early universe had itself a spin on very large scales. The entire universe had a spin, basically, and that has affected the likelihood of smaller systems to spin one way or another, thereby taking up some of the overall spin. Another possibility is that we misunderstood something about the plasma that formed in the early universe. Indeed, one of the theories which could give rise to such correlations is that of a fractal universe. The idea of the fractal universe is that the quantum fluctuations that gave rise to the motions of the plasma in the early universe had a self-similarity, a pattern that repeats from very large to very small scales. As an example, look at the Julia set, one of the best studied fractals. It's full of spirals and they all turn the same way. If the plasma in the universe had such a fractal pattern, that could also explain why we observe too many large supergalactic structures that violate the cosmological principle. I'll admit that this surprised me. This is why I like doing science news. You never know what's the next story that the universe will spin. Thanks for watching. See you tomorrow.